Hello everyone. Our project is detail preserving fluid control using smoothed particle hydrodynamics. This is based on a paper implemented by Nicholas Thierry and group. In this project, we are using the Fluids V2 SPH simulation framework. We have modified the framework to suit our goals. The main goal achieved by this project is to create a target-driven SPH fluid simulation by using control particles. We use scale-dependent force control to preserve the small-scale fluid detail. To achieve this, we import a low-polygon animation mesh sequence exported as OBJ files from Maya, which have both movement and deformation. For the first frame of the animation sequence, we regularly sample a 30 x 30 x 30 grid to insert control particles by performing the triangle intersection tests. The control particles are then displaced for each mesh of the animation sequence using the mean value coordinates algorithm. Thus, we find the new position of the control particle for the remaining frames. In this algorithm, every vertex of the mesh contributes a particular weight to the position of the control particle. These weights are calculated for the first frame and then used to find the new positions of the control particles. The red particles represent the control particles. We can see that they indeed follow the animation sequence. The control particles exert control forces on the existing fluid simulation. These control forces are made up of two scale-dependent components, the attraction force and the velocity force. The advantage of these forces being scale-dependent is that fluid's natural behavior is preserved and control particle is sufficiently covered with fluid. We first implemented the control forces for a stationary mesh. We can observe the behavior of the SPH particles when the control forces are switched on and switched off from the video. All the SPH particles which are blue in color are attracted to the control particles which are red in color to take the shape of a bunny. We can also observe that these SPH particles are not clogging and are evenly distributed. Finally, we can see the same for the animation sequence. As the velocity of the mesh changes, control particles' direction also changes and we observe the splashes. We are using approximately 3200 SPH particles and 2300 control particles in this simulation. A further improvement to this project can be to reconstruct the mesh and observe a target-driven shape. We want to thank Professor Kawan for his inputs. Thanks for watching.